Welcome everybody. I'm going to dive right in because this is probably going to be a longer video because I'm going to go over some Lego math, and this is not the basics, okay? So I'm assuming you know some basics of Lego math and how everything works. I'm going to get into the more complicated master's level stuff of calculating and making things come together. In order to do that, I've got this really cool simple little build. It doesn't really mean anything. It's just used for pure Lego math. Okay, so I'm going to start by talking about this triangle right in here. Okay, what I've got is two Technic 15 pinhole length lift arms. There's a pin there, there's a pin there. I'm just going to go by this one. From there, it's going vertically to 1, 2, 3, 4, 5. 2 halves make 6. 6 bricks tall. 15 on the hypotenuse. And this length is 13. Let me try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Great. 13, 6 bricks high, 15. And by the way, what's really cool about this is 6 bricks high is equivalent to a Technic 1, 2, 3, 4, 5, 6, 7 and 1/2. So 7.5 Technic of these pinhole lengths would be equivalent to that 6 tall brick structure. So this side is basically brick using system height, because Technic would be 7.5, which is a weird number and wouldn't work. But the other lengths are working with the Technic pinhole length system. And what's great about this little construction is a little bit about geometry. So I'm going to go through a little bit of geometry. I know you hate math, but sorry, I got to do this. I got to do this because it's so cool. Okay, there is a triangle with magical properties. We all know that, you know, this side squared plus this side squared equals this side squared, or square rooted together, you know, blah, blah, blah relationship. 30, 60, and 90 are even more special because 30, 60, 90 means that if I know the height here, x, this length will always be 2x. Okay? So right away, using Lego math, 6 height is 7.5 Technic. Multiply that by 2, you get 15. So I'm using the weird wonky relationship of how 12 bricks high would be 15 Technic lengths. Okay? Or you could reverse the math down to make it simpler. But basically, you get to this weird point where 7.5 is 6. 7.5 times 2 is 15. And if you do the math in pure mathematical forms, it's roughly 12.99, but that's probably a rounding error. Cross that out, it's 13. Okay, so that's why that length was 13, this length was 15, and this thing is 6 bricks high, or 7.5 Technic. Awesome. Okay. Boom. So the other cool thing that's going on here is I'm using cheese slopes, because what is roughly 30 degrees? Answer, there's an element. It's called the cheese slope. The cheese slope is listed differently in certain places. It's listed in some areas as 30 degrees, some areas as 31. It turns out that it is really 30.96. So I'm going to go with 31 degrees. 31 degrees means they're not perfect. Can you see that 1/10 of a millimeter gap? So it's hitting the front. But under considerable load and strain, they'd start to fold flat against that. But when we talk about Lego, you know, this ABS does have flex to it. It's how the clutch works. We're actually straining the sides, and they're what's gripping the studs. Same idea. If it's that close, it's close enough for me. So another cool thing with the 30, 60, 90 frame here is you can use cheese slopes so that you can throw that away This structure will still be perfectly in system for any vertical members you want to put in, but you're not reliant on building up bricks if you want to. It's just perfectly going to work out, okay? So that I can do that and then lay it flat against the cheese slope. Another interesting thing comes to effect, and it can be proved and demonstrated here, which is, and I didn't learn this until very, very recently. Thank you, Tricky Brick Stream and chat, for this. But if I take a Technic brick and I take a Snot brick and I use the studs of the System Snot brick and I put them into the Technic hole, it turns out that there is a 1/10 of a millimeter height difference between them. And this goes way back to the way things were molded. So if you look closely, there's a 1/10 of a millimeter gap on the bottom of this standard brick, and there's a 1/10 of a millimeter gap on the top of the Technic brick. So if I try to plate across this, you can see those gaps, if I squeeze it properly, are introduced. Now, in all practical matters, as an AFOL and a mock designer, I've done this where I've done an illegal connection of this nature, and it hasn't really caused problems in the model because I'm not relying on it too much. I'm just cheating in order to get to something I need. But over long distance, there's something that might be a problem, okay? Which is why set designers can't do what I did. They cannot attach top and bottom, these cross to cross. If you have Technic to a Snot brick or System going to the Technic has to be independently built, lying flush against, and only relying on this one connection, but you have to build everything off and you can't bind them across due to that height difference, okay? But that's showing up. That's showing up in this model because if we think about this triangle, if this part is solved technically with Technic, this part is only solved with bricks and their height, and I crush everything super flat as hard as I can to try to prove the point. Put that down, put that down. Lo and behold, there is your height difference showing up in the model. Okay, just reinforcing the fact that the System and the Technic are going to eventually meet in some point, and they're going to not agree mathematically, but engineering-wise, you can gronch it, you can field engineer it and make it work. So that's an interesting little side discussion, which I'll throw that brick over. The last thing I want to talk about is how I did the cheese slopes. So let's talk about Snot. This is a Snot tutorial now. We're transitioning from the former discussion into a second discussion. This is a really great exercise on Snot math. So cheese slopes are nefarious little elements in that they have to be molded with a 1/2 plate height offset at their base, okay, which introduces a 1/2 plate offset if you want them all to line up completely like that together. The way I did that is by introducing this bracket. Brackets have a 1/2 plate height, or this is 1/2 of a plate, which means if I manipulate that, instead of 2 plates high or 1 plate high with it being 1/2 plate too low, the 1/2 plate introduced by the bracket makes this line up perfectly with this as my baseline, the second brick, which is lying flush against this piece, which I'll talk about. Okay, so by using brackets, I've managed to build this up and have these two cheese slopes lie against each other. The next thing that's going on is bricks that we normally think of as vertically. I'm using this way, which is a great, that's the Snot thing, is you start to turn things 90 degrees. And the Technic math always is pin, plate, pin with a brick. So brick, plate, brick. Always 2 plates. Okay? And that's one of the reasons, not the reason, but one of the reasons that these Technic holes are odd numbered is this is the smallest reinforcing connection I can make, which is 3. 1, 2, 3. So by having odd numbers down there, if I'm ever reinforcing the standard brick, plate, plate, brick, it's going to be an odd number and work out really well. Okay? So this is one of those basics that you learn and memorize, but you know, Technic, plate, plate, Technic. Turning it sideways. Let's go forward from where I solved to this point, okay? So coming here, the other problem that would arises is if I used a standard Snot brick, the standing tall and out, there would have been a gap because this Snot brick, when it stands up, if you notice the plates are, this side is always a half plate to, you know, up off the ground, so to speak. And that's where this next little piece comes in. So instead of having a one plate too far to the right, in this instance, I'm using what I call a snout brick. I know it's got a very technical name and whatnot, but this brick was specifically designed to address this type of problem where these studs are molded into a two-plate high system, not a full brick, but because it's 1-2 high, the studs are then that half plate closer to where it studs in. In this instance, it means I can make this cheese flush against this wall over here. Okay? It does present a problem because now I've got two plates, and then I need to come in and lay in my next brick with that half plate offset to make it flush. Right? So looking at it, it's like 1, 2, and then a half, a weird half. The way to solve that is by adding a plate and then using the true Snot brick right there, and because the Snot brick is 1/2 plate up off the ground, boop, you clear the studs and you're lying flush against them instead of using them as connectors, the ones here. So that now this cheese slope is flush against this side, and just the way that Snot brick math works out, I've managed to descend another half plate downwards so that that cheese lines up. So 3 cheeses in a row now are as flush as they can be. I can put that in there. I can then take my Technic brick, okay, and I can lock that in, covering up that gap, doing that, and then coming back to my original little idea of let's talk about the 30, 60, 90 mathematics of a triangle using Technic and System, and the beauty of this structure that you could use in any number of ways, or just as a thought experiment, along with the fact I can throw in that 31-degree cheese slope, and just even from here, the human eye, you'd have to have really good vision to notice that it's not absolutely flush. People are just going to look at it and read it as if, oh, this is you know, lying against that. It's clean, it's smooth. I could put, you know, the stud pins in, the half pins with studs, and throw in tiles or whatever and clean that up and get a really nice finish. It's all up to you. But this is just Lego math at a master's level kind of discussion where we're getting beyond like stud, plate, plate, stud. This is getting into some pretty hardcore stuff and talking about some of the little inconsistencies that we can demonstrate and how to start to go from Technic to brick and back and forth between these systems, and throwing a lot of snot in the bottom just because I can. All right? Be well. It's almost 15 minutes. Far too long. Take it easy. If you made it to the end, if you're actually getting this, that's awesome, okay? See you later.